In this nugget, you and I get to take a look at the details regarding Telnet from the eyes of Wireshark. Let's begin. Telnet has been around as long as I can remember, and the benefit of using Telnet is that an administrator, for example, sitting at a PC right here, connected to the network, can go ahead and open a Telnet session to manage R1 or a Telnet session over to R2 to manage R2. Telnet leverages the layer 4 protocol of TCP and the well-known port on the server, the Telnet server that's listening for incoming TCP connections for Telnet is going to be listening on TCP port 23. So we're going to use this topology with R1 and R2. We'll set up R2 to receive Telnet sessions and to authenticate users as they come in. And then what we'll do is we'll go ahead and put Wireshark and we'll capture the traffic that's going back and forth between R1 and R2. And then we'll analyze that TCP-based Telnet session through the eyes of Wireshark. So let's make sure that R2 has the ability to be logged into via one of its VTY lines using Telnet. And so what we'll do is we'll go into configuration mode on R2. We'll say line VTY 0 through 4, which will cover the first 5 VTY lines, and we'll say login local. Now, from an iOS router perspective, what that means is that any inbound connections that are trying to come in on the VTY lines, such as a Telnet session, the router is going to prompt them for a username, and they're going to have to display a username and password, and the router is going to use its local database, the running config, to validate the user's credentials before giving them access on the VTY lines. Which leads us to our next challenge, is that we don't have any usernames by default in the running config of a Cisco iOS router. So let's go ahead and create one. We'll create a user called admin. We'll specify a privilege level of 15, and we'll set up the password for this user to use as nugget bang23 with a capital N at the beginning. And one of the benefits of using the keyword secret instead of the keyword password is that this will be encrypted in the config as opposed to being stored there in plain text. We want to avoid plain text whenever we can. And we will exit out of configuration mode. Next, let's make a road trip over to R1. And on R1, I just want to verify that we have basic connectivity between R1 and R2. Looks like the first ping failed and the last 4 made it. That very well could have been through ARP resolution. And now that that ARP entry is cached, let's go ahead and do that ping again. And now we have 5 out of 5. That's a great starting point. We have basic connectivity. Next, let's start our packet capture. So I'm going to go to GNS3, which is where this is being created. We'll right-click on the link between R1 and R2. We'll click on Start Capture. We'll click on OK. And then I'll go ahead and we'll minimize Wireshark, and we'll come back to it in a few moments when we need it. So let's start our Telnet session, and we'll use R1 as a Telnet client, and we'll use R2 as a Telnet server. So at the console of R1, we'll type in telnet space and then the IP address of R2, which is 10.0.0.2. It's prompting me for a user account, which is admin. It's prompting me for the password for that user account, which I'll supply. We'll press enter, and now we are successfully connected over to R2 on one of its available VTY lines. And we're using Telnet to establish that connectivity. So for example, if we did a show TCP brief, that would show me from R2's perspective the current TCP connections it has in place. So here R2 is saying I've got on my local address of 10.0.0.2 TCP port 23, I have a connection, and that connection is going over to 10.0.0.1, which is R1, and 10.0.0.1 is using the port 12,746. And that's because when R1 initiated this Telnet session over to R2, it chose some currently unused high-numbered port and allocated that port number for use for that Telnet session. And the server, of course, is using the well-known port of 23 as it communicates back and forth between itself and R1 over that Telnet session. So if we bring back our packet capture, and I'm going to click on stop here, I'm also going to go to GNS3 for a moment. And in GNS3, I'm going to right-click on this link and tell it to stop the capture as well, because we have the capture data that we're looking for. And then back in Wireshark, we can use this icon right here to go to the very first packet in this packet capture. And here we have the 3-way handshake that we're using with TCP to establish a reliable session. So there's our SYN request, our SYN-ACK, and our ACK, which is great. And then followed by Telnet data, meaning the payload that's being carried is Telnet. So if we grabbed, for example, packet number 9 and looked at the details of it, if we looked at the layer 3 header information, the source is 10.0.0.1, that's R1. The destination was 10.0.0.2, and the next protocol in this protocol stack it's pointing to is TCP, which is protocol number 6. So if we collapse layer 3 and we expand layer 4, here we have the source port of 12,746, which R1 chose to use for this Telnet session. And the destination port is port 23, which is the well-known port for Telnet. If we looked at a Telnet packet that was being sourced by 10002, for example, we'll grab packet number 11 that was going back to 10001, you'll notice that the source port from the Telnet server is port 23, while the destination port is the port number 12746, which is where R1 is listening for incoming traffic regarding that Telnet session. It's also important to be aware of the source and destination ports being used in communications when we're applying access control lists in our network. Because to create a proper access control list that does what we want it to do, we need to make sure we're blocking the correct ports involved in a communication. And then if we collapse the TCP information, we have our Telnet payload. Now, friends don't let friends run Telnet. And that's because all of the data is sent in clear text, which means for you and I that anybody who's eavesdropping on our traffic is also able to see all the commands that we're sending to the router or to the switch or to that Telnet server, which includes our user account information as well as the passwords that we're authenticating with as we authenticate using Telnet. And to make matters even worse, protocol analyzers like Wireshark make it very, very easy to go ahead and reflect exactly what's going on. And in the world of Wireshark, we could right-click, for example, on any one of these Telnet packets. And from the drop-down list, there's an option for Follow TCP Stream. And if we select that, the characters in red are characters that are being sent to the Telnet server. The characters in blue indicate traffic that's being sent from the server back to the client. And that gives us the benefit of seeing commands as we type them in. So it prompted us for a username that was coming from the server. We typed in admin. It echoed back each one of those characters. We could see it as we typed it in. Then it sent us the line saying, please give us the password. And then we supplied nugget bang23 as the password. And because passwords are not echoed back, that's why we don't have a blue character for every one of these red characters in the password that we supplied. And then once I was logged in, I did a show TCP brief. And the red characters are me typing in the commands, and the blue characters are the Telnet server, in this case R2, echoing those characters back to the screen so I could see them on my screen. And then the output from show TCP brief, all of that was being sent from the Telnet server R2 over to us, and that's why all of these characters are blue. And even if we didn't have some type of feature that could show us that TCP stream information, we could go to each of these Telnet packets. For example, if we go to packet number 25, we could take a look at all the packets that R1 is sending over to R2, meaning that they're coming from the source address of 10001 going to 10002. And if we look at those, and then we also take a look at the Telnet data below, which is unencrypted, we can see what's being sent. So in packet 25, it's an A. And then packet 27, there's a D. And then there's an M. And there's an I. And there's an N. So that's us providing our user credentials. And then what's about to happen is we're about to send our password. So there's the capital N as part of nugget exclamation mark 23. There's the U, the G, and so forth. So again, we should rightfully be very concerned about using Telnet in a production environment because of the risk that a clear text protocol like Telnet brings to the table. In this nugget, we invoked Telnet, we captured it, and looked at the properties using Wireshark. The capture that we created in this nugget is available as part of the Nugget Lab files for this course. I have had a great time in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.